I want to, there's a big word up here that you've seen before, right? Proportional. Where have you seen, or what does that word mean? Where have you seen that word before?
Geometry.
Math. Right? What does it mean?
Have one relation.
Paolo, what is it?
It's a relationship between like two numbers, like the proportions between like the characteristics of two like quantities.
Sure. Right. When something is proportioned to each other, they have something in common. They have a relationship. Right. Right now, you guys are working in geometry, and if I was to say these two, and I know they're not drawn very well, but if I said these two triangles are proportionate to each other, what could they have in common?
Equal size. What do you mean?
Equal
size.
Okay, no, they're not the same size, right? How would they have equal size?
Well, you said.
Okay, so if I said there was an x, that this side of the triangle was x, right? And here's y. Okay? And let's just say, I think Christina was the one that brought up the vocabulary word ratio, right?
Yeah.
Okay? So I could calculate the ratio by taking x and dividing it by y, right? And getting a number. Yes?
Yep.
Is this? I mean, it's been a long time since I've been in geometry. Correct me if I'm wrong. Can we do this?
A ratio. Yes, you can.
Okay. All right. So if I did it to the smaller triangle, same thing. Had an x, had a y, took my x, divided it by y, and got a number. What could I say about these two? If these two triangles are proportional,
The ratio are the same.
They would be the same, right? Z would equal Z. Okay? All right, this is just to try to get you understanding that proportional is a word you've heard before, okay? And this is very much going to tie into what we're doing. In math, you're just working with numbers, okay? I want you to start bringing in that math so that we can solve these problems, okay? All right, now, what are we looking at here on this slide?
Ingredients.
Yeah.
Ingredients for what?
Cookies.
Cookies. Okay, according to this recipe, how many cookies can I make?
5 dozen.
5 dozen.
12 times 5 is another 60.
Okay. All right, now.
You really had to overthink things, don't you?
Raylee, if I asked you, what is the ratio of vanilla extract to sugar, what would it be?
Which one is brown sugar?
Brown sugar.
Oh, brown sugar. Oh, my.
So, okay, so the ratio is what? Say it loud. 1 to 3/4, right? That's probably not a very good example. But the ratio of vanilla extract to brown sugar is 1 teaspoonful for every 3/4 cup. What is the, Jasmine, what is the ratio of baking soda to eggs? 1 to 2, right? In order to make my 5 dozen, I need 1 teaspoon of baking soda for every 2 eggs, right? To make my recipe happen, okay? All right. Sela, what is the ratio of eggs to dozen? 2 eggs for every 5 dozen. Good. So it's a 2 to 5 ratio. Yes, are you with me so far? Okay. Present? So what if I told you I have 5 eggs? How many cookies can I make? How could we solve this?
You'd have to do,
You gotta actually
you have to put in 2 over 5, and then you have to do, 5 over x, or y, I guess. X, y, you know what I mean?
2 eggs.
Okay, okay, yes, I do know what you mean. So you're saying to do 5 eggs, right? Over X, because that would be my unknown, right? How many cookies would that make? And that would be equal to?
And then it would be 2 over 5.
2 to 5. And then what do you do from that point?
Cross multiply.
Cross multiply.
2x would equal 25.
Divide the 2x by 2 and repeat the same thing, and then you get your answer.
And you get 12.5.
Okay.
So it's 12.5 dozen.
I totally forgot about this. All right. let's look at another way, the way that we've been doing to solve for conversions. Okay. What number, if I was to do, okay, pay attention. If I was doing my railroad, what number always goes here?
The number is given.
The number given. And in this case, it's 5x. Okay? All right, now, I need to know, to solve this, the ratio of eggs to cookies, which we said already was 2 to 5. Yeah? All right. So now I have a 2 to 5 ratio that I'm going to use here to convert. Which number do you think I'm going to put here? Am I going to put the 2 or the 5?
2.
Why 2?
Because the eggs are going to be next to each other.
Yes, because I need to cancel out my units eggs, and I need eggs, and 2 is representing how many eggs, right? And I know that in every 2 eggs I can make 5 dozen. Isn't that the same thing?
Yes.
Okay, multiply the top, divide by the bottom. 25 divided by 2 is 12.5. Okay, same thing. Now, the reason why we have to do this in stoichiometry this way instead of your other method is because we're going to be going from one compound to another. So, and I'll give you an example in a little bit, but I may have a problem where it's saying I have 6 moles of carbon. How many moles of carbon dioxide can I make from that 6 moles? Okay? And so we used a recipe here. In stoichiometry, a chemical equation is like our recipe. So can you go to the next slide? I don't really like the definition that's on the next slide. Keep going. Because it seems very, I don't know, wordy. The definition I like is this one, and I want you to write this definition down in your notes, okay? The quantitative relationship between the amount of reactants used and the products formed in a chemical reaction. RXN refers to reaction. What does quantitative mean? Numbers, right? That's all you need to know at this point. It's the numbers, okay? But stoichiometry basically is looking at the numbers of an experiment, right? How are we going to get that chemical equation to go? To react. And it says, according to the other definition on the slide, that it's based on mole ratio. And we've already been talking about ratios. In this case, the ratio number comes from our coefficients. And so here we have a 2 coefficient for magnesium. What is the coefficient here for? What is the coefficient for this oxygen here? What is the coefficient here? How do you know? It's 1. It is 1, but some people say there's no coefficient here. If there was no coefficient, it wouldn't be in the problem. Okay, so if you don't see a coefficient, it's an imaginary 1. Okay? When we're looking at ratios, we're looking at the coefficients, and those are the big numbers that come in the front of the compounds. So what is the mole ratio of magnesium to magnesium oxide? using the coefficients. 2 to,
Or, wait, for what?
for magnesium to magnesium oxide.
2 to 2.
2 to 2, okay? That means I need 2 moles of magnesium to produce 2 moles of magnesium oxide. That's what I'm saying, okay? What is the mole ratio of oxygen to magnesium? 1 to 2, right? I need 1 mole of oxygen to produce 2 moles of magnesium, okay? It can be asked many different ways. What is the ratio of magnesium oxide to oxygen? What is the mole ratio of magnesium oxide to magnesium? All you're doing is looking at the coefficients, okay? We're not looking at the subscripts, the coefficients, okay? So if that's the case, what do you think the number one thing we need to have before we start a stoichiometry problem? What has to be true about this problem, this equation? It has to be balanced. Good job. Okay, so go ahead to the next line. So here are the steps. I keep pulling this up and down. What are the steps? I want you to write these steps down. Okay? In order to solve a stoichiometry problem, you have to first have that balanced equation. An unbalanced equation will mess you up from the beginning. Okay? Step number 2. You need to identify the known and the unknown. And that's pretty simple and straightforward. The known is the number that they give you in the problem. The unknown is, what is it asking you to solve for? Having that written out, understanding which conversion you're doing from the very beginning is going to help you, is going to help guide you to your final answer. Number 3 isn't going to make too much sense right now because we haven't practiced any yet. And actually, I'm only going to have time to work one out just so you can kind of see it. Tomorrow, we're going to do practice, okay? And I'm trying to break this up in sections so that it doesn't become so overwhelming. So we're going to start off first with just a mole to mole, okay? And we're going to do, I'm going to show a mole to mole conversion today. And then in the next coming days, I'll show you the others. But there are several conversions that we can do. We can do a mole to mole, which would require the mole ratio. We can do a moles to grams conversion, in which case we need the molar mass. We can even do a moles to liters of solution, and we call that molarity. We'll talk more about that. That's a new vocabulary word. And then we're going to do a moles to liters gas, and that was molar volume. Essentially, all of these problems rely on the mole ratio, those coefficients, and having a balanced equation. Okay? Are there any questions so far? We haven't taken this many notes in a while. It's like... All right, once you're done, I'm going to do that practice problem with you. We're good? Yeah. We okay? All right, so what do these problems look like? All right. All right. Again, we're just, for now, all we're gonna do is a mole to mole ratio, okay? So the question, let's see, Sarah, I like your voice. Can you read the question number 1, please?
How many moles of iron chromate
Yep.
chromate are required to produce 44 moles of carbon carbon dioxide.
Yes.
How do I not know this?
You do know it. You're good. Okay, so she just read the problem, and I'm going to do a conversion of mole to mole, right? I'm going from moles of CO2 to moles of iron chromate. Okay? Before, in our other conversion problems, when we were dealing with carbon dioxide, we were doing conversions of just carbon dioxide, moles to grams to parts to parts to moles to grams, right? Now we're going from one compound to a whole brand new compound, okay? So, what number is always, and it's still going to hold true now, what number is going to go in the first square? Christina? Number it gives me, and what number is it giving me here?
44 moles.
44. 44 moles of CO2. Okay? Now, I don't have much else to go on. All right? And this is where that mole ratio, it comes into play, and it becomes important. And your chemical equation is your recipe, remember? Your recipe is going to tell you how much you need to make this reaction occur. And according to this, I need 8 moles of carbon dioxide to, the ratio would be 8 to 4, and I would need, let me say it this way. I need 4 moles of iron chromate to produce 8 moles of carbon dioxide, okay? Now, the problem isn't asking me to go from iron chromate to carbon dioxide, it's asking me the other way. So what is my ratio of carbon dioxide to iron chromate? 8 to 4. Did I confuse you right there? Jasmine's like, yes, you did. I'm sorry, I didn't mean to. All right, 8 to 4. What number do you think is going to go here? Well, yes, I need a moles number, but am I going to use the 8 or the 4? I'm trying to get from carbon dioxide to iron chromate.
4, right?
What do you think? 8. Why 8?
Because we already have the moles for the carbon dioxide.
Okay, because I need to have my moles of carbon dioxide canceled, yes?
Mm-hmm.
Okay, and it needs to go diagonally. I'm trying to get to moles of iron chromate. All right? I know that if I have 8 moles of carbon dioxide, how many moles did I use to get that 8? 4. That's part of my molar ratio. Okay? Yeah? Huh. Des? No? Okay, what do I need to do now, Desiree? Can I keep going? Do I stop? Can I stop? I mean, I could keep going, but should I? I'd rather not too. And I don't have to, because my top number over here is moles of iron chromate. That's my stop sign. That's what I'm trying to find, moles of iron chromate. I have my unit up here. I can stop here. Okay, now it does. What do I do? Yes, you do know. What were we doing with the top numbers?
Oh, you multiply?
You multiply them. So 44 times 4, and then what? Divide by what? 8. Put that in your calculator. Whew. 22 what?
Uh,
22 what? What does that number represent? 22 is just a number with no unit. Moles of iron chromate. Alright, what does this all mean? You know? Really, what are you solving for?
Yeah.
This is what you're solving, okay? The problem is telling you that you have 44 moles of carbon dioxide. How many moles did you need to make, how many moles of iron chromate did you need to make that 44 moles of carbon dioxide? 22. I had to start with 22 moles here to make the 44 moles over here on this side. Do you see how we crossed over a yield sign?
yes.
We went from reactants to products. So we are looking at the quantitative relationship of the reactants used and the products that are formed. I look confused. Are we okay? Show me with your thumbs. Are you like, I don't even know? Are you like, I need more practice, but I can see where this is going?
I know that.
Or are you like, am I at least like, are you understanding some of the words I'm saying?
Yeah, it's like is that an egg?
Okay, I mean, oh. If you're like this, I'm happy with you like this, okay?
Yeah.
Well, I was like this.
If we're like this, then I need to know what your questions are. Where did I lose you?
With the first step.
Give me one place, Sarah. What was confusing?
The first step throughout the whole steps.
Okay.
Yeah.
The very first step, though, Sarah, all I did was put what it gave me. That didn't require any thinking.
True.
All I did was put the number from the problem and put it in the first square. Okay? Desiree, what did I do next? What did I do? I put my 44 here. Where did these come from?
What are those things called?
What are they?
I forgot what they're called. I don't know what those are called.
Okay, these we call subscripts. These we call coefficients. Okay, so these came, and where did those coefficients come from, Desiree? Did I just make them up?
No.
Where did they come from?
From the existing equation.
From my balanced equation. Okay? Now, of all these numbers up here, how did I know to use 8 to 4? How did I know to do that? Christina, okay, Christina, how did I know to use 8 to 4?
Because in the question, and it has those thingy there.
You want to come point to this?
Yeah.
Okay.